Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, September 16th. Looking at significant wave heights for the South Pacific Ocean, we see a gale producing 42-foot seas southeast of New Zealand and clear of the Ross Ice Shelf. But the issue is, most of this energy is aimed more southeast than northeast, preventing much of the swell from reaching up into our forecast area. Otherwise, a reasonably calm pattern is in play. Let's get into the details. As usual, we'll start this week's tour looking at Jetstream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales form, help direct their track. We're looking for a trough, and we actually kind of see one right here. That is a push to the jet stream to the north. There's actually some wind in this trough too. What is that? 140 knot winds lifting to the north. That helps set up a counterclockwise flow aloft. Actually, clockwise flow in the southern hemisphere, and that, of course, is the hallmark of low pressure. And also, it does the same thing down at the surface. And, of course, low pressure generates winds. Winds generate seas, and seas, as they radiate away from the fetch area, hopefully to the north, produces swell. When that swell hits your beach, it produces surf. So we have sort of a trough here in the far southeast Pacific, but also notice remnants of a ridge. That's the exact opposite of the trough, pushing south. We have a major ridge here in the southwest Pacific pushing south, and that pretty much stomps on potential for low pressure development between. So there's the northern branch of the jet, here's the southern branch of the jet. When you get this sort of split pattern with a ridge pushing south, you get high pressure here. But that doesn't mean that there isn't a little bit of potential right here, like south of New Zealand, for gale development. But if whatever gale does form in here would likely be pushed south or southeast, and that's what we think is happening and associated with that gale that we saw producing 42-foot seas south of New Zealand. Anyway, moving on. So we look as we move into Monday, the ridge breaks down a little bit, but it sweeps to the east, and the ice line right now is somewhere around 63, 64 south. So the jet, in essence, is pushing over the Ross Ice Shelf or Antarctic ice, and only of interest to maybe penguins in Antarctica. Nothing happening over the open seas, clear ice-free seas of the South Pacific, at least not according to this model. And not as we get into Wednesday, we get into Thursday, here comes another ridge, into Friday. Just pretty much everything looks locked down. Now here's a bit of a trough developing on Saturday, but the Southern California swell wind is like 117 west, so that's pretty much only of interest to Chile then and Peru. We watch this. Here comes another big ridge building as we get into Sunday, pushing south, almost a trough under New Zealand here on Sunday also, but no real wind energy pushing up into it. All the energy just is, it's been this way, for 2 months now. A ridging pattern, and all the energy just pushing south into the central Pacific, just stomping on any potential for storm development. And that continues to be the pattern as we get a week out into late Sunday next week. All right, let's go take a look down at the surface. And here we are, surface level pressure, surface level winds. Remember, there is not real, the jet stream's like falling like that, and you can just look at the wind arrows here pushing southeast. Yes, we have a gale, 45 knot winds, but notice even in the gale, there's a little bit of a northeast push on the far west side of the gale, but as you get into the east side of the gale, decidedly the winds are pushing to the southeast, and so the bulk, we'll say the bulk of the winds, if you average it all out, is maybe due east. And what we really want is a gale lifting north with fetch pushed to the north and northeast. Instead, we have a gale falling to the southeast with most of the fetch aimed east or southeast, and not particularly good. The gale actually makes it through, amazingly, to Monday. And look at that, even a little tiny area, 40 knot winds pushing northeast. So maybe a little hope of swell from that if we get lucky. And then we get into, we're into Wednesday now. We're just looking for signs of anything. Here's another little fetch, 35 knot winds, but they're all aimed southeast too. Nothing develops there. We're really looking for 45 or 50 knot winds. We get into Friday. Here's another gale, only 35 knot winds aimed off to the east. And that falls southeast, and it just is the pattern. It doesn't seem to be breaking up at all. And basically any gale, yeah, you get a bit of activity under here, under Tasmania, but as it moves into the Pacific, it just gets pushed to the south over ice and just shut down. And that appears to be the pattern for the next week as well. All right, let's go take a look at wave models. So first off, we're going to go back in time a week to last Sunday, the 9th of September. There was a little gale that developed, what was that, 36, building to 46-foot seas over a tiny little area. Now the Southern California swell window, again, is like right here. So this is actually out of the Southern California swell window. Most of the energy here is aimed to the northeast, but a tiny bit of swell is expected pushing north, and it's been radiating that way for a week and is expected to arrive in Southern California come Monday morning. Nothing huge, just a small pulse of swell, maybe also reaching up into northern, exposed south-facing breaks in Northern California, but size will probably be something considerably less than what we've seen for the past 3 or 4 days, something like that. That system moved out of the swell window. Then we're looking another tiny little system pushed south of New Zealand on Monday night. This one actually offers a little bit of potential for Hawaii. Seas were 37 feet, and then it almost tried to lift northeast, and we'll just put that back into motion there. So there we are. Where is this? It's down around 56 south, and just look at the motion. It's east and then slightly northeast. So a tiny little bit of swell is expected into the South Shore of Hawaii in the early part of this week. Not a lot of size, though. And then we're just going through the week real quick, and you can see nothing really happened until where we are Sunday. So here's today. Let's move over to the current wave model. And here we go. That's that system. What is that? 42, well, 41-foot seas, we'll say. And continuing into tonight, all moving off to the east. We'll just sort of put this in motion. There you go. To the east. Maybe almost lifting northeast slightly, a degree or two as we get into Monday. Seas fading from 30 feet, and then it all fades out. So maybe a little potential for small sideband swell. Not a lot for Hawaii. Maybe better for California. Certainly more so for Central America, Peru, and Chile. Then we'll just go the week out. We've already looked at all the models. We don't see a whole lot going on. Something pushing under New Zealand on Friday, 31-foot seas, but that all peters out. And then another, just bits and pieces of energy trying to squeeze under, but the big ridge, just way too much in control. And you see, we ran the whole way through the week there. Here, we'll just blast through it again. You can see literally nothing going on, nothing forecast, and just kind of a quiet pattern indeed. With that said, let's take a quick look in the North Pacific, and you see, okay, one tiny little gale with, what is that, 22-foot seas, but they're all aimed north up into the Bering Sea, and you just roll this out, and you can see just literally nothing going on here either. In fact, let's do a quick look at the Jetstream. So here we go, 250 millibar winds. So normally this time of year, you'd expect to see the jet somewhere around 45, 40 north. It was a pretty active year and pretty strong along here, but watch how this goes. I mean, yes, you see pieces of it trying to fall south. You see a lot of energy still pushing north, suggesting, and that's like a cutoff low there. That's not going to do anything. Big ridge. So all this sort of smells a lot of high pressure down at the surface pushing the jet north, or at least weak energy in the jet pushing the jet north, or not enabling it to push south and supporting high pressure down low. You just watch this. Yeah, a little cutoff low. There has been this sort of tendency lately for low pressure to develop in the northern Gulf pushing southeast. And that's probably been the only ray of hope. And you see just not a strong jet stream pattern, not one decidedly pushing to the south. It still smells very much like La Nina, and typical of La Nina. You get a lot of high pressure early in the fall season, and it just takes a while for fall to get going. And that's what the atmosphere is looking like. Like La Nina is still here, though we know something else is trying to organize, but it's just not there yet. So that leaves us looking for wind swell. So we're looking for winds at least 15 knots, preferably 20 or greater along the California coast or east of the Hawaiian Islands. Yeah, we see patchy areas of 15 10 to 15 knot winds. And this is, what, 900 nautical miles east of the island. That's not a particularly beautiful-looking picture in terms of generating wind swell for Hawaii. For California, certainly no hope at all. Little bit of winds as we get into Monday, 20 knots over Point Conception. And again, this patchy northeast pattern east of Hawaii. Just not doing a whole lot. Now notice this. High pressure, 1024 millibar starts building on Tuesday. Winds start picking up along the California coast, 15 to 20 knots. A little bit off the coast. Maybe good for some very short period wind swell. And then the southeast and south quadrant of this high really gets, look at that, like a wall of 20-knot winds pushing towards Hawaii. Maybe that will stir up some wind swell. It's still the better part of 600 miles east of the islands. But maybe as we get into, look at that, and just sweeping east, as we get into Wednesday, wind swell will develop along exposed east-facing shores of the Hawaiian Islands. Fetch typical almost summer, here we go, back to a summertime pressure gradient along California in late September. Not a good sign. Again, all this just smelling of La Nina completely with high pressure in control. 20 to 25 knot winds off Northern California. Yeah, that'll make for some wind swell into Central California for sure. Same thing into Thursday. East winds continuing into Hawaii on Thursday. Wind swell there. And then look at this. Low pressure kind of sets up. Actually, let's look back. Yep, it just sort of materializes along the Washington coast. Yeah, and that kind of cuts the legs out of the high, which is 1032 millibars, quite strong. I mean, if I was just looking at this picture out of the blue, I'd say this is a July chart if I didn't know that it wasn't September. So that's not particularly favorable. And the high just sort of lingers out here, blocking. I mean, what we really want to see is that high gone. You want to see the jet dipping down in here, low pressure moving into the Gulf of Alaska. We're not seeing it. Wind swell dying out. Just a weak wind pattern for Hawaii as we get into the weekend. Same thing pretty much for California. So in terms of swell, yeah, mixed little bits of wind swell. We see southern hemi swell getting ready to push into southern California. Little bit of small southerly swell working its way into Hawaii, the Hawaiian Islands the early part of this week. And then maybe a little bit of swell from a gale that's currently pushing east under New Zealand, maybe something a week out, a week to 10 days, but probably very small in size. And just the North Pacific is asleep, so not a whole lot going on swell production-wise, even in the wind swell category. So let's take a look long term. Let's see what's going on with the MJO and possibly El Nino. And we say possibly with underline that exclamation points because it is not a for sure thing at all. So first up, we'll start looking for the presence of the MJO, the Madden-Julian Oscillation, a periodic oscillation that tracks from the West Pacific to the East Pacific on the equator. It actually goes the whole way around the planet continuously. And the active phase in winter months tends to support the formation of gales in the northern hemisphere. And in summer months, sometimes not as a direct correlation in the southern hemisphere. Of course, the inactive phase of the MJO kind of steals energy from the jet, helps promote high pressure, and that doesn't do anything for producing anything other than wind swell. All right, so what are we looking for? Well, here we are. We're West Pacific here, East Pacific here. This is the equator. This is New Guinea here. These are winds, 5-day average winds from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino. They're showing solid easterly winds the whole way to the dateline there. Then they mysteriously kind of drop off, suggesting something's going on here in the West Pacific. So we a little bit more detailed view. Look at anomalies, differences from normal for this time of year over this region. We see, yeah, those winds are pretty much normal, a little bit stronger than normal here in the dateline region, the areas, let's say south of Hawaii to the dateline. Okay, a little bit more easterly than normal, but over here in the West Pacific, just a slight tendency to be from the west, suggesting maybe some sort of weak active phase of the MJO is over here in the West Pacific. Let's look at the wind pattern for the past couple of days. So here we go. There's South America, Central America right there, Australia, New Guinea, Kelvin Wave generation area. The main area we're interested in, the area from, let's say, the Philippines, 135 east to 170 west, and 5 degrees north and south of the equator. So draw a box in your mind right there. And that's where we want to see westerly anomalies, because westerly anomalies in that area help to produce a Kelvin wave. And sure enough, on the 10th of September, we had westerly anomalies. Same thing on the 11th. 12th, it sort of faded off. 13th, and by the 14th, they were all but gone, suggesting whatever active phase of the MJO has steadily been weakening through the 14th. And then here's another way to look at it. This is 850 millibar zonal wind anomalies. That's up about 4,700 feet in the atmosphere. So this chart is the whole planet on one chart. Again, just zonal wind anomalies, the east-west component of the wind. Kelvin wave generation area, 135 east. So from about here to about here on this chart. So you just look straight up in that area and you can see, oh, here, August, September. Lots of yellows and oranges suggesting westerly anomalies. That's and the blues are easterly anomalies. So that suggests probably some weak active phase of the MJO has been going on in the early part of September. Now this is interesting. Here we get into, here's the date line. Here's our easterly anomalies. We saw that on the other charts. But in the western half of the Kelvin wave generation area, still westerly anomalies. And this whole thing is only supposed to last, well, these are 1, 2, 3, maybe 4 days. And after that, boom, here we go, starting a developing region of westerly anomalies. So whatever this is, it's supposed to be short-lived. I wouldn't call it the inactive phase of the MJO. Then we move back into what could maybe be considered a weak active phase of the MJO. Not too bad. All right, let's look 2 weeks out. So this is outgoing long-wave radiation models, another way of looking at MJO-related anomalies, okay? If you see blues, that's the active phase of the MJO. That means more cloud cover, less sunlight reflectivity off the ocean surface, meaning low pressure. Well, right now, looks like we're in a dead neutral pattern. That's supposed to hold, but per the statistic model, the active phase is maybe supposed to develop about 2 weeks out. The dynamic model, it says the exact opposite thing. Right now, yes, neutral MJO, but then maybe turning inactive. So, a complete 180-degree difference of opinion 2 weeks out of what's going on between these two models. Then we look at phase diagrams. So this is another way to figure out where the active phase of the MJO is. Assume you're looking, how do you read this chart? Well, assume you're looking down on the North Pole, and the MJO moves from west to east, from the Indian Ocean over the Maritime Continent, through the West Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. It does this circle over months of time. And let's say the active phase would be moving across the Pacific in maybe a 3 or 4 week interval, maybe up to 6 weeks. Then the inactive phase would follow for anywhere from 3 to 6 weeks. The heavy dot's where the active phase of the MJO is, so sort of in the Indian Ocean. And if it's inside this circle, it's considered to be extremely weak. The green line is the forecast for the next 2 weeks. If anything, it's supposed to retrograde and build into, it looks like maybe the Atlantic, Africa area. So that would say 2 weeks out, there might be another pulse of hurricane activity. The active phase of the MJO certainly supports the development of hurricanes. So possibly hurricanes in the Atlantic, that per the ECMF model, the GFS model, says basically the same sort of thing. Interesting. Then we look at the 40-day upper level model. So yellows are areas that are not supportive of precipitation, green supportive of precipitation. So this says some sort of inactive phase type thing is there's Central America right there, the equator right there, South America, New Guinea there. So you can see yellow moving into Central America through the 1st of October. So inactive phase, the MJO, followed by an extremely weak, maybe active phase of the MJO, traversing the Pacific through, maybe the end of October, and then followed by a weak inactive pattern. You know what's really striking here is just how incredibly weak the MJO is. Now, you say, well, what's that mean? That's not a good thing. Well, actually, it kind of is, because during the formation of El Nino, typically what happens is the MJO completely disappears. It just fades away or gets very weak, and what happens is the El Nino basically acts like a continuous active phase of the MJO. It just suppresses the MJO itself, but takes over and basically does the same thing as a non-stop active phase of the MJO. Now, that's a bit of a reach, because El Nino right now just doesn't appear to be doing anything at all. We almost, the other way you could look at it is we're in a dead neutral pattern. I mean, the atmosphere isn't doing anything. If you just look at this on the face, it's like we're in La Nina, but there's no MJO, and everything's asleep, and there's no swell production, really. It just seems like we're in a dead neutral state, which, in fact, we are. But, all that said, there's something else going on. So, okay, this is from the CFS model. UV component, 850 millibar wind anomalies, basically the same sort of chart. Here's the 2 tick marks we're interested in, so the area from about here to about here going down. And what do you see? We see lots of reds, and what's red mean? So this is past history. This is June 22nd. This goes out about, what, a month or something like that, 2 months. Anyway, lots of westerly anomalies have been setting up in the Kelvin Wave generation area in the dateline. And see all these little guys here? Every one of these is some sort of tropical system, either tropical storm or a named hurricane or something. So things have been exceedingly busy in the Pacific. And notice how these tropical storms get real active during these periods of westerly winds, which typically would be the active phase of the MJO. And you can see it sort of clustered around there. Not necessarily, but, and here's another little cluster here. Okay, so here's the forecast. Yes, we got this little thing here. What's this? It's a dotted red line. Oh, here you go, red line. Equatorial Rossby wave. So not MJO related. And what it's supposed to do is create a little bit of easterly anomalies over the Pacific for, maybe 3 or 4 days. Then that fades out. It actually, over time, retrogrades off to the west, disappears, and then boom, back to westerly anomalies, filling almost the entire Pacific basin, starting, let's say 5 days out, and fully filling the basin. I mean, that's as far in the West Pacific as you can get there, and this is California's at 117, so the full Pacific basin filled with westerly anomalies, supposedly starting, let's say, a week from now and continuing out for a month into October. All right, let's go look even further. All right, so here's the longer run of that model going out 3 months, and instead of looking down, past history is down here, and then the forecast is up here. So this in August was kind of what we're calling a westerly wind burst. Oh yeah, and Kelvin wave generation area between about from here to here going up. Heavy yellows suggest westerly wind bursts. That helps create Kelvin waves, and Kelvin waves are essential for the formation of El Nino. So we're here, and there's our little bit, putting things in perspective for the next 3 months. There's our little bit of easterly anomalies for 3 or 4 days. And then what do you see after that? Well, this has been consistently on the models, this large, non-stop westerly wind burst that goes from maybe like October 3rd to November 3rd or more, and then even fragments of it continuing into November. That would be a way to transport a lot of warm water that is sitting over in the West Pacific to the east in the form of one or multiple Kelvin waves. And we already know that this little guy here already started to create a Kelvin wave, and if that doesn't look like much compared to that, then it suggests that something rather interesting is going to happen in the next month, let's say. All right, so let's overlay. What do we got? Okay, so the dotted lines here are the inactive phase of the MJO, and that's very weak, like one contour. Here's a weak active phase, and you see that sort of drives the westerly wind burst. Another inactive phase, but just very weak, and, even back here, back in July and June, 1, 2, 3 contours, 1, 2 contour active phase. Now we're into a far weaker pattern as we get from here. Why is that? What's going on? Well, okay, let's overlay the low pass filter. And here you go. So what's this all about? 1, 2, 3 contours. This solid contour is, and this is all sitting in the Kelvin wave generation area. Actually, there's California at 120. So as we get into about the first week of October, the entire Pacific basin is supposed to be filled with this, what we call low pressure bias. And that's a classic hallmark of the development of El Nino. And not only that, we go from 3 contours to 4 contours as we get into November, and holding steady from there. So the model, if you believe the model, is saying that some sort of El Nino is supposed to be developing. Also, notice here, this is high pressure bias sitting right over California. That's already broken down, is supposed to get even more broken down. And then you see here, here's where the core of the high pressure bias is supposed to be. And we'll just say it right here. This is the Indian Ocean. So this low pressure bias has been sitting in the Indian Ocean for 2 years. And you wonder why all the Mentawai Islands and all those places have been getting just bombing surf for 2 years in the summer months. That's why, because the low pressure bias was here. Now, supposedly, the atmosphere is going to flip, and the low pressure bias is going to move into the Pacific, and the high pressure bias is going to move into the Indian Ocean. That's the hallmark of El Nino. And so, why is the Pacific asleep? Because the atmosphere and the ocean aren't coupled yet. That is, yes, the atmosphere is making the transition, and it appears to be doing that steadily. I mean, this is all confirmed past history here, and you can see, yes, low pressure bias setting up in the Pacific, but it takes a while. It's a big ship. Things just don't turn on a dime. It's not like, oh, a thunderstorm pops up and there you go. No, this takes months for this transition to occur from moving, for the atmosphere and the ocean to sort of start working together. And, once you see the atmosphere supporting low pressure, and then what happens is down on the equator in the Pacific, then storms start popping up on the equator, and that starts transporting moisture and heat energy up into the upper atmosphere, and that starts feeding the jet stream. And then and if it stays that way long enough, month after month, then you get what's known as El Nino. But we're not there yet. We're just turning towards that. We're like, okay, we just got out of La Nina, basically. I mean, literally, like 3 weeks ago, the atmosphere started saying, okay, La Nina, I think, is dead. We're dead neutral right now. It's probably going to take another two months or more for some sort of El Nino to really start manifesting itself in the atmosphere and for signs of it starting to show. The issue is here, as, we're in September. We're still waiting for El Nino to form. Odds are it's not going to get really good momentum this winter. It'll be a slight, weak El Nino pattern. We've looked at some long-range model, and they're suggesting maybe this is just the start. It maybe won't be till next winter. So not winter of 2018-19, but not till 2020 that we really get some sort of a solid El Nino pattern established. So something to consider. All right, so we talk about this coupling of the atmosphere and the ocean. So what's going on in the ocean? Subsurface temperature profile, West Pacific here, East Pacific here. This is just on the equator, 2 degrees north and south of the equator. These are the anchor lines on the TAO buoy array. The X's are the sensors on those anchor lines. And what do we see? Well, this is 30-degree anomalies. That's 30 degrees Celsius anomalies, basically warm water in the far West Pacific. 28-degree isotherm line. We look for this to be moving east if El Nino are really developing, or if a good Kelvin wave are going. It's pretty much lock steady at 60 west right now. That's like south of Hawaii, basically. The 24-degree isotherm line had retrograde back to like 125, maybe 130. It now is starting to move off to the east some, so that's a good sign. And it's still, there's plenty of warm water at depth. I mean, the 24-degree isotherm line's going down almost 125, 150 meters down. So that's pretty good. We just want to see more energy moving off to the east. So we look at anomalies, differences from normal for this time of year. And what do we see? Bing! Big old pocket of warm water, 4 degrees centigrade above normal, sitting at, what is that, about 145, so south of Hawaii, a little bit southeast of Hawaii on the equator. This is a Kelvin wave. This is a classic Kelvin wave developed or generated by, remember we saw westerly wind burst back in, when was it, August some time frame? Westerly winds took this warm water here, started pushing it to depth. It started moving off to the east, and here is a pocket of warm water, and the expectation it's going to continue east and erupt off of Ecuador here. You already see some forerunner of that energy, 1 degree, little 2 degree pockets starting to erupt to the surface here. Nothing super solid, but the thought is that is the start of what we're calling Kelvin wave number 2, the second solid Kelvin wave this year. Here's another model, same data, just a different model trying to fill in the gaps, guess at what's going on. 1, 2, 3, 4, 1, 2, 3, 4. So 3.5 degree anomalies. And warm water building, a little pocket of cool water here off of Ecuador, see that? But Kelvin Wave starting to push east. This is the, we think, the upwelling phase of the last Kelvin Wave cycle, just about dying out. New warm water pushing east, and that is a good sign. Upper ocean heat anomalies, this sort of lays it all out so you can see what's going on. West Pacific here, East Pacific here. Time, December, January of this year. You see a little tiny Kelvin wave started in January, pushed east and kind of dissipated. But this was La Nina last year in the November-December time frame. That pretty much killed La Nina, at least it made it look like it was. Then February, major westerly wind burst occurred. Kelvin wave made it partway, kind of stalled, and then finally pushed in the June-July time frame into Ecuador. Right in here is our upwelling phase of the Kelvin wave cycle. That's that little pocket of cool water. Here's the next Kelvin wave developing, looking as big, if not bigger, than the last Kelvin wave, and it too is going to start pushing off to the east. Now, it takes about 3 months, so it didn't even get organized till, let's say mid-August, so that's September, October. Sometime mid-November to maybe early December, it would erupt off of Ecuador, start creating warm anomalies there, but that's kind of late in the season for, that's not enough to really get us into, that might start us for El Nino, but if you were having a strong El Nino, we should be already at this point back in the June time frame. So if nothing else, this is just sort of putting the death nail in the coffin on La Nina and pushing us towards a warmer regime. But will we get into a real El Nino? Hard to say. All right, so we've talked about the MJO. We've looked at the subsurface, but it's really what's going on the surface that really matters. Surface sea temperatures, okay? And what do we got? Well, looking here off of Peru and Chile, we see cooler water. So this is the Nino 1.2 region right in here. Not an official El Nino monitoring region, but just an area you kind of want to watch because trades in this area take warm water here, start pushing it off to the west. The official El Nino monitoring region starts at 120 west, 5 degrees north and south of the equator, so box right along in here. So what we see is, we see upwelling from the early maybe parts of that Kelvin wave starting to erupt on the surface. And then we see a scattered, partially lightly warm pattern in the official El Nino monitoring region. But we still got these persistent, just cool pockets of upwelling going on here that have just been a real problem. This is why we say there's this battle going on between El Nino trying to develop and the fading remnants of La Nina hanging on. And the atmosphere and the ocean just aren't in sync yet, and they can't get organized. And so we're basically in what we'd call a neutral state biased warm. The trend for the past week, 7 days, you see these blues, these are pockets of water that's cooling over the past 7 days, kind of markedly so right here near the Galapagos. But then you also have these, we had some pockets of real good warming over this area over the past week. They're starting to back off a little bit. So just kind of this mixed bag pattern, not really warming, not really cooling, just can't make up its mind what it wants to do. And then the overview pattern, sea surface, 5 kilometer sea surface temperature anomalies. You see, yes, warming, but mainly on the equator and north of the equator, scattered pockets of warming south, but also scattered pockets of cool. We really want to see warming down to like 10 degrees south and north. We see it good in the north, just not in the south. That's been the problem. And light warming, official El Nino monitoring region, right in here. Kind of a mixed bag. In fact, let's go look at the temperatures. Here's the Nino 1.2 region, the area there right up by Peru and the Galapagos Islands. It's been pretty cool down around minus 0.75 degrees for the past, since June. Just in the past couple of days, boom, it's kind of pushed up 0.5 degree above normal. This is the warmest it's been for months, let's say that. So that's a good sign. But still, just looking at all the charts, it doesn't look particularly warm. It doesn't look like it's going to keep going. And then in contrast, we look at the Nino 3.4 region, the official El Nino monitoring region. The trend has been, the temperature has been about 0.25 degree above normal. It takes 0.5 degree steady for, 6 months, 9 months before you get into what they call El Nino. And what are we today? Dead zero, 0.007. So again, no clear signs of El Nino, not necessarily any clear signs of La Nina either, just kind of a dead neutral pattern. So what's the CFS model say for temperatures in the Nino 3.4 region? Well, where are we? We're in sometime in September, so right around here, hovering right around, it says a quarter degree above normal. We're barely there. And supposedly, temperatures are to be heading up at, let's say, 0.75 above normal as we get to October 1st, and 1.25 degrees above normal as we get into November. That seems highly optimistic. Now, we know there's a big Kelvin wave, and it's supposed to start erupting in the East Pacific, equatorial East Pacific, somewhere in mid-November. So that's probably what this model is keying off of. And then it says temperatures is to hold about 1.25 degrees above normal through April of next year, and even then only falling to maybe 0.95, still almost a whole degree above normal. So when we start talking about, well, maybe this, our thoughts is this is overblown. We'll get somewhere around maybe 0.75 to 1 degree above normal, which would be an El Nino, but a weak one. But maybe, just maybe, if it's weaker this year, it would be next winter that it would actually be a bit stronger and more pronounced. And just looking at the way the atmosphere is going, I mean, you know, you guys can read the charts, keep your eyes on it for yourself. But at this point, kind of looks like, well, this seems overhyped. Let's go look at some more data real quick. Southern Oscillation Index here. Difference in pressure between Darwin, Australia, and Tahiti. When you have this index, the daily index, being negative over a long period of time, that suggests at least the active phase of the MJO. And if it's even longer, for like months at a time, then that would suggest El Nino. Well, we were negative for a couple days there at -30, but where are we now? Plus 7.43, and have been positive the past 5 days, so not so good. So let's average out. The 30-day average takes some of the noise out of it. -3.30, that's just below normal, and we were actually more negative than this back in August. So we'd say this is kind of a neutral MJO pattern. The 90-day average, that's how you can start looking for El Nino. -2.73 a month ago, went down to -4. Where are we today? -3.19. So basically no change, just hovering at, we'll say, neutral, bias towards a very weak El Nino. And then the index we're more interested in, this is precipitation in the atmosphere and the difference in the areas, two different areas north of Darwin and then over the equatorial Pacific. The current value has fallen. It was up positive at about 0.2. Now we're down at negative again, -0.24, meaning less precipitation in this area. You can kind of go see it right here, the Galapagos, that area. So this is this whole deal again. There's cool water here. Yeah, there's some warm water, but there's like warm water on the north side of the equator, cool water on the south side. The two of them kind of average out, and they're not enhancing evaporation. You got to have warmer water to get evaporation, and then when you get evaporation in the atmosphere, then you get precipitation, and when you get precipitation, then that starts feeding energy into the jet stream. But what this is saying is we're just a shade below normal, and we're toggling back and forth between this and +2, which says we're dead neutral right now in this region, not biased at all towards El Nino, but we don't think we're in La Nina either. Again, the atmosphere is just trying to get coupled with the ocean. They're trying to figure out what they're going to do. They're just not going to flop instantly from La Nina to El Nino. It's going to take some time, and that's why we believe the models are overhyped again, and that the transition to El Nino will not be an immediate thing that's going to happen in a 1-month period like the CFS model says, and all of a sudden, boom, as we get into fall, things just start breaking loose. Probably not. Maybe it'll happen. It'd be great if it would. We're not counting on it. We're thinking more of a slow transition. So, in that theme, right now we're supposedly in the transition to fall. We're not seeing it. The atmosphere looks like it's La Nina, high pressure locking things down. Yeah, there's little pieces of storms in the South Pacific, you know, maybe a little bit of small swell here and there, but basically less swell activity is expected over the next couple of weeks as compared to what we've just had. There was some nice southern hemi swell this weekend, a little bit slow, but you know, there were waves. Take what you can get, and actually last week it was pretty good, especially in Southern California because of the extreme south angle, not so much in Northern California. And that's supposed to continue. North Pacific not coming online. We're looking for wind swell. Yeah, we'll get that because there's high pressure. And then the long game here is still waiting on El Nino, or at least waiting for La Nina to die out. I think we can safely say it's dead, but we're not moving aggressively or even moderately towards El Nino right now. We're just dead neutral. The atmosphere is trying to sort itself out. But maybe in the next month or two, we're figuring as we get into October, we'll have a much better handle on what's going on. So that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.